Alright, good evening YouTube. This is the shipping container garage. Today I want to show you the cool part I figured out to make using 3D printed tooling and bench press vise. Not very complicated tooling. This is something a lot of people have at home. So I've been really trying to figure out ways to broaden the 3D printed press tooling market. So this is a copper tube that I made from a round shape into an oval shape. So the bulk of this video is going to be dedicated to the how I did that, but before we jump into the how, I want to explain the why. So the reason why I want a round to oval shape is I have a 1969 Volkswagen car Magia, and I'm shoving a 3-liter flat 6 Subaru engine into the thing, as well as a split case 6-speed reversed Subaru transmission. So this is a huge project. But the main reason is the cylinder heads on the 3-liter are equipped with these nice big oval intake ports. Got 6 of them. They're all taped up right now. And oval shapes are not easy to work with when you're a DIY guy. So the math says an oval shape will flow a certain diameter in round. So that specific size is a 42 millimeter. And that's where I got these Wave Runner ITBs. These are ITBs that you can split apart. They got a nice big flange that you can mount stuff to. So I'm going to make a dual set 3 and 3 on each side. So we still need to go from round to oval. So that's where the 3D printed press tooling comes into play here. So this guy is a pretty special little part. So it's got the round shape on the one end, and then down on the bottom it's got an oval shape. Now the main problem with 3D printed press tooling like this, once you press that piece of copper on, if this is a solid piece, that stuff is stuck. There's no way to get it out. If you push the plastic out, well, you just made an oval shape for the entire thing, and you can't go backwards because, well, then it's back to round. So you have to make these parts disassemblable. So this part took a couple iterations to get right, but the core intent is that the center pin will drive out, and then these angled wedges in the middle here, and the sides here, will push to the middle where the rod was, and then it will allow the full assembly to collapse and drop right out. So that is the why I decided to investigate how to 3D print a tool to press copper. Now let's get into the how I did it. So without further ado, enjoy the rest of the video. Alrighty y'all, so I'm gonna heat treat the copper. I got the 3D printer making a new press tool, and that'll be done in the morning, so press it in the morning, but we gotta heat treat this, get one chore done tonight. So I'm by no means a metallurgical expert, but this is the way I was taught to anneal coppers. You get it bright red hot and you drop it in a bucket of water. So that's what we're gonna do. I know this is a cutting torch, but this is the nozzle I got on it right now. We've got the piece of copper laying on the... I got an old vise here. Got it from a neighbor when they moved out. I'm kind of a sucker for old tools. As long as we're gentle with our heat, it's not going to hurt anything on this vise. We're almost to the point. When I did this last, I got the copper not too far away from the red hot zone, so I'll make sure this guy's good and hot. This guy's pretty close. Yeah, that's about it right there. Hurry, hurry, hurry. Alright. So I was told you can anneal these guys multiple times. This is the first one I did. First time I did this, it didn't have the black material on it. I'm wondering if that's oxidation. Not sure. Either that or just the water was dirty. Anyway, This should be nice and soft, and we'll be able to press this tool in the morning. Alright, the parts are done. Let's go try them out. Clearly a two-handed job. See you out there. Alright, so here's all the pieces. The oxidization or whatever that black sooty stuff was kind of wiped off with a rag, so not quite sure what that was. It's still a little bit there. Okay, moving on. The first operation we have to do is we have to use this tapered part to taper the tube size to the correct size. So that'll be our first press. Next press here, now you get to see the part in partially assembled form here. So if you haven't seen my first video, the idea is that the copper gets pressed down from this direction. Once you press it and it stretches over the part, like this guy, there's no way to get the thing off. So in order to accomplish that, I have a pin in the center that will get driven out, and then the angle on these guys will allow these center pieces to drive to the middle and drop out, and once they do that, then this guy can collapse and it should slide out of the copper. For this version, I made some speed holes to speed up the printing. It should be plenty strong. So yeah, let's get that retaining ring down. So let's see here. As you can see, the size of the tool was sized so that when this guy is pressed all the way tight, it's going to touch the retaining ring on the bottom there. So I think that's it. All that's left to do is stick it in the vise and try it out. Alright, we got it in the vise with the blue speed square, and let's just start pushing. Let me back out here so you can kind of see. I'm barely having to give this guy any force. Once getting to the end there, it's getting a little stiffer. I can see a little bit of bowing taking place. So it's working. And there it is. Pull her out. Nice and flush. I don't know if you can see it on camera, but I can definitely see and feel a taper. Okay, so I'm going to pause this, drive the plastic out, and we'll take a measurement with the caliper, see what it did. Alright, so the 27mm socket looks like it's going to do what I want it to do. So we're going to lightly tap. It's coming. Yeah, I need something good and circular to give it a good even distribution of force. Alright, let's take a look here. I see copper color. Oh, that's a bummer there. This is a really fast and easy part to print, so if this guy gets nicked up, that's okay. So let's take a look there, and let's see what the calipers say. Let's see if it did what it was supposed to do. I am real excited to see. Okay, we're on millimeters, and let's see. It's supposed to be 42 1/4. Doing this thing 0. I did. Am I measuring the right side? I don't think I am. There it is. Wow. A little bigger. That's okay. Wow. Yeah, a little bit imperfect. Either that or I'm just not getting the jaws in very well. And, you know, the further in I go, the tighter it's going to get, right? So all I need is that it'll fit over that guy. Alright, so I got it in the vise and I got her started. All I did was a little bit of deburring and then push these guys together. Just a tiny bit. Before we go any further, let's get a backer plate behind the copper so we don't ruin the copper. Okay, I'm looking at it from the side here and I'm just making sure everything is straight and level. We don't want to be pushing this guy out of level. So this is requiring a little bit more force. And I'm seeing a little bit of crookedness, so I gotta readjust here. Alright, so I started seeing a little bit of deformation on the plastic, and I don't want that. So I'm gonna pause, gonna clean this up, and I'm gonna go and press this guy deeper into the part and try and open that hole up more. Alright. Ooh, yeah, that's doing a good job. I can watch the copper being bulged. It's pretty impressive. I don't know if you're able to see it on your screen, but I can definitely see the bulging on mine. You know, I might as well just send this all the way. It'll just be just a little bit less work for this guy. I really need to anchor this vise. I'll be very curious to see what the plastic tool looks like at the end of this press. Oh, there we go, there's the bottom. Alright, so it's been taking a little bit more hammering to get this guy free. But it's coming, little by little. I don't really want to stick this in the vise and hammer it. You know, I could let it sit on that edge there. I really just don't want to mar up the edges if I can help it, because of what this will be used for, right? It's not intended to have a marred surface. There she goes. Alright. Let's take those calipers again and see where we're at. 41.73, 42.20. Let me turn so we can all see. 42.22, 41.65. Interesting. We got a uneven press. I can't say I see any real imperfections in the tool. Oh, that's interesting. See those two marks there? It's not necessarily like a gouge, it's like it's smoothed out with pressure. That was these little marks right there. They're still there a little bit. Less prominent. Okay, where were we? Let's see. This is the side we pushed through. This should be the... let's double check. If the cheap calipers hold 0. 42.05, 42.09, 42-ish. So yeah, depending on where you take the measurement from, it's just a little bit under. So we may have to go print another one of these wedges with a little taller taper. This is all an experiment. Still got to take a look at this guy here. Alright, I ran the tool through again, and I was getting a consistent 41.9, 41.8, and I think this is the reason why. I've always known my printer prints outer perimeters slightly different than it does inner perimeters. So as far as can you make a accurate pressing tool to achieve the size you want, you can get pretty darn close. I don't remember the exact conversion from millimeters to thousandths of an inch, but this thing's pretty friggin' close. I'm going to try one more time in the big press tool, and if we can't get it to seat right, I'm going to have to print another taper tool and push it through and push her through again. So let's give it one more shot. Alrighty, we're going to give her a whirl. Got her seated. Alright, so I paused to take a look. I was seeing a tiny little bit of shavings coming off. Not a whole lot, not as bad as what we saw on the other press tool, where we were seeing a lot of shavings come off, but they start small, so we'll see if they grow. Let's keep pressing. So far it's looking good. I can definitely see bowing right there. Wow. This is really impressive to watch. I can totally feel that thing bulging right there. I want to make sure this thing's got a good solid surface contact, give it the best shot it can. So this guy's taken, I would say, more force than the little guy took, which is, you know, expected given that this thing is so much bigger. Man, this is killing me not having this guy bolted down. I may have to move the little camera stand and press off camera, but I'm going to try my best to get this whole thing pressed. So I'm going to try and show how much force I'm having to put into this guy. And this plastic is taking it. I can't believe it. I'm not seeing any shavings coming off this thing, so the annealing and the chamfering seems to be the trick. Oh, there it goes. So I just remembered another trick you can do. You can tap the handle with a dead blow. That's making it easier on me. So if you're stuck like this, try the tapping. I just can't believe how well this thing is working. There's a couple tiny little flakes coming off. Barely anything though. This is just amazing to me. Promise next time I'll get my vise bolted down. Everything still looks pretty straight. I just can't believe how well this thing stretches over this copper, or this plastic rather. I mean, look at that, there's no gap. No gap under the flat spot. That's wild. Alright, we're almost there. This is so freaking neat. Good grief, this is cool. So didn't see it all the way down, and it kind of looks like it might be not flat on the bottom. We'll set it on a flat surface when we get it. Yeah, that thing's bowed. So that's something that didn't account for in the design of this thing. So if I make a lot of these, we're just gonna have to make sure they're all flat. Okay, let's see if we can drive that pin out. I made the pin slightly undersized, not hugely undersized. That guy's in there good. I'm gonna have to punch that out. Okay, for anyone else that tries something like this, I found the 7/6 or the 3/8 1/4" drive deep socket is working great to push this guy out. It's not going to go all the way, so I'm hoping this thing frees up by the time we get down there, or we'll have to push it with something else when we get down there. Once we get to the bottom, there should be a lot less resistance. So I'm just tapping it out lightly with the hammer here, and it's going pretty easy. Okay, so the pin's out. A little bit of a tiny bulge or something from punching it, but that's not too bad. Now the trick is going to be convincing the wedges to pop out. I think last time I had to use a chisel and push a little bit of force down with an angle. So I'm going to try that I'll let you know how it goes. I'm going to lay this in the vise, push from there. Alright, so I used a little itty bitty 6mm wrench, pushed on that, and look at that! Gave it a little tiny nick, but that was in the part of it that wasn't actually pressing, so I'm okay with that. So, I didn't actually clamp that in. You don't have to. So I'm going to try and push this guy out, and for this one I'll see if I can set this up to where we can see it pop. Let me set this up. Okay, let's try this. Try this again here. That works pretty well. It's narrow enough to contact the edge. You know what, we can get the box end on it. Ooh, this one's real easy. Ah, of course. Let's see. Put that down. There we go. Bam. Oh, just like that, huh? Wow. Oh, sorry, I used to put my hands down there. Wow. I am thoroughly impressed. Let's take some measurements. See where it's at. What did it do to the circle? Looks like I might have pushed it out a little further. Oh, that one's bigger. Yeah, that's doing better. Hey, I'm seeing good measurements here. Okay. Now, memory serves correct. This should be, I think, a 51.5 or 51.25, somewhere in there. And I'm seeing 51.35. If I go all the way in, right, it's just going to get smaller and smaller. It's only right at the end there that it's going to have its final dimension. 51, 48, 47 or so. And then across, that was like 30, 33 or, shoot, I don't remember, 33.5, I guess. Well, I can't really measure that guy easily. I'd have to put it back together. Let's see, as far as consistency, we're on the one end here. 33.6, 33.6, back in the middle. 33.65. In terms of consistency, my goodness, that's impressive. Alright, to close out the video, I brought the copper part out to the engine, stuck it on here, and you can see that shiny aluminum. Let's see, that's aligned right there. See the shiny aluminum appear and disappear as I move it? This thing is like so close. Let's see. If we're looking over there, bring it that way. Oh, and it just barely appears over there when it disappears on the other side. I am really excited about that. I think it's gonna be hard. It's gonna be hard to say, but I think way down in there, there's a tiny bit of overhang. Let's see if we can zoom in. I think the copper is overhanging the intake just a tad. So that's a bummer, but we might need to re-evaluate the shape of our oval and see if we can make it a little closer. However, we may be able to print a small wedge shape, kind of like we did for the initial tube push, and reshape only the bottom. Or we might have to just deal with the potential small amount of performance loss. Or either that, or just after we braze this thing into the plate, you know, the bottom of the intake plate, and just grind it away and make it flush. So a couple options, but man, this thing is so good, dude. It is like dead on. All right, I'm really impressed. It's very similar when you put this up to the underside of that ITB, but it's kind of hard to film one-handed. So, all right, that's gonna be it for today's video. See y'all later.